Yes, this is unique among uniques, if I am right, and there are very small chances that I am wrong. Although before this I presented a diamond with corundum on it several times, which I determined by measurement, no one reacted to that fact. Now, however, the question arises whether it is possible to create a combination of diamond with painite. Why? Because the layers of the Earth's crust and the types of substrate as well as the conditions under which they are created and in which we find painite and diamond are completely different. Practically, if you consult gemologists, it is practically impossible to have diamond and painite in the same stone because they are formed completely differently, but it is theoretically possible. In fact, nature has proven many times that often something practically impossible for her is easily feasible and possible and achievable. Of course, no one has found such a stone yet, but I am showing it right now. Not because I'm stubborn or trying to cause a sensation, but because all measurements, visual and colorimetric parameters undoubtedly say that I have diamond and painite in the same stone. Look carefully at the pleochroism clearly visible in this shot. I slightly changed the position of the stone in relation to the open window in the middle of a sunny day. The light first falls on one side of the stone, then on the other side of the stone, and then on the third side of the stone. The shadow also changes sides, and the effect of pleochroism is clearly visible because the color changes noticeably from dark brown, orange to violet. The refraction of light is extremely beautiful, visible both in painite and diamond, each in its own way. The hardness and density of the stone do not leave the possibility of mixing it with dravite or garnet in that color, because the measurements are made at the same time and in parallel with the measurement of the hardness of garnet and tourmaline. In every measurement, this stone is harder than them. If there is another crystal with that hardness and color and characteristics, then it is some unknown, newest type to which I will then give a name. Painite shows very visible pleochroism even with a camera, and the values of density and hardness are correct. On the other hand, diamond is the complete opposite of painite. It is a single crystal with strong light dispersion and the absence of pleochroism. The surface texture with many triangles and flat sides of the circle shines very brightly with an adamantium shine when it is under light. There is also a penetration or decomposition of light that does not allow you to see the spatial structure of the diamond. In Vroma, the refraction of light and the internal energy that light creates in the diamond are beautifully visible. In this piece I decided to show the surface texture that is clearly different in these two gems. The diamond is in painite and I don't know how far it goes inside, but where it comes out through the painite crystals it is very nice to see and recognize. Now listen carefully. How to recognize a crystal? This is a winning combination that I will show on the example of this stone. When you start looking for gems, the first thing you need to do is study the quartz well. There is a lot of quartz in nature and it is simply inevitable that you will have it on every stone. It is very similar to almost every crystal because its shapes are variable, and it is very important to recognize it because otherwise you will collect a lot of quartz thinking that it is something else. Measuring the hardness in situ by scratching and breaking is one of the common methods that gives me the right picture. Again, when you have oblong crystals and crystals that have strong light dispersion, then quartz is automatically eliminated at the beginning, as are many other crystals that are not composed of oblong crystals. What I achieve in this way is that by eliminating possible crystals based on facts, I arrive at the right answer to the question in my hands. By measuring hardness, I mostly confirm my assumptions based on the characteristics that I cross and which eliminate the crystals most similar to the one I am considering. In this sense, diamond is the easiest to prove. It is enough to measure the hardness. Yes, an ascending diamond-bearing magma, like kimberlite, can physically rip off, assimilate, and mix with crustal or shallow lithospheric rocks, including boron and zircon-bearing skarns, during its violent upward punch through the Earth's crust. Geological mixing mechanisms. Magmatic assimilation. As gas-rich mantle magma races toward the surface, it shatters and melts wall rocks along its conduit, incorporating foreign crystals, xenocrysts, and rock fragments, xenoliths. Geologically, it is impossible to find natural diamond and painite in the same rock. They form in completely different geological environments, temperatures, pressures, and chemical compositions. Diamonds are formed deep in the Earth's mantle, about 160 to 240 kilometers deep, under extreme pressure and high temperature, and are brought to the surface exclusively by deep-seated volcanic rocks such as kimberlite and lamprophyre. Painite is an ultra-rare calcium zirconium borate mineral that forms in shallow metamorphic environments, especially in skarn at the contact zones between marble and boron-rich granite rocks. The different geochemical environments required for ultramafic rocks formed in the mantle that carry carbon, diamond, do not overlap with the boron and zircon-rich metamorphic rocks of the crust, painite. The possibility that exists is a unique opportunity that even the greatest prophets would not have predicted. During a volcanic eruption, however, deep layers of kimberlite intersect and mix with shallow layers of marble and granite crustal rocks rich in boron and zircon. It is possible, and this stone says that it is practically possible. Yes, an ascending diamond-bearing magma, like kimberlite, can physically rip off, assimilate, and mix with crustal or shallow lithospheric rocks, including boron and zircon-bearing skarns, during its violent upward punch through the Earth's crust. Of course, for now, everything is unconfirmed, but given the very extensive analysis and deductive selection, there is a very small chance that my assumption will not be confirmed. am a child born in a volcano. I sleep under the glow of lucky stars, I bathe with bears and wake up with the silent stumbling of a fast mountain river. My logic is simple. I can make mistakes just like any other person, because I don't have a laboratory and the instruments that the world's scientific centers have to prove what I actually have with me. Yes, in order to be 100% sure, you need to do a chemical analysis of the composition, but it is precisely those elements that make up the mineral that determine the appearance of the mineral, the specific gravity, the hardness, and all the other properties and parameters of the precious stone. I offer you prestige and the #1 position on the world scene of precious stones. My gems are in many ways the best in the world right now. Of course, only if I am right about everything I have stated here, and there is a very small chance that I am wrong. All interested, passionate, serious collectors and scientists can contact me via email, urkjsn@gmail.com. I'm a gem hunter and I'm especially looking for rare and specific gems, and this is one of the most exclusive ones I found a few days ago. I hope that my videos will help in understanding precious stones and crystals. A big greeting for all collectors, lovers of precious stones and crystals, and especially for gem hunters.